All right, so that's recording. Okay, shall we start? Okay, so here we will explore some true facts about FRP browser programming with Reflex in Haskell. My name is Niklas Hambu, and I have a company here in Switzerland. I'm a software consultant, and most of my Haskell time I'm spending with FP Complete, a company you might know. We do things like this, so like training on topics. We also do software development, and we are also quite a co-ed doing like project management, deploying things into production environments and so on. So today we'll explore this very interesting setup of making websites, so the GUI parts, not the server parts, of websites, using GHC.js and the Reflex FRP framework. So here's a short introduction. So GHC.js is a compiler, like a variant of GHC, you could say, that turns Haskell into JavaScript. JavaScript is something that you don't need to know what that is, actually. So we'll straight go to FRP, which is functional reactive programming. So in our case, this means that you have some values, and these values can depend on some other values, and they will automatically update when the dependent values change. And in the same way, you can have some GUI elements that will automatically re-render when some of these dynamic values change. And this is very convenient because this means you do not have to do all this manual updating that you typically have to do in like writing websites with JavaScript directly, listening to events and then like changing things. Instead, you can just declare down your website and it will automatically reflect the updates to the various values that you have. And we will use two libraries. One is called Reflex, which is a generic Haskell FRP library. You can use it for everything, but it comes together with this sister library called Reflex DOM, which allows you to use Reflex-style programming for elements in the browser document object tree. So here's a short overview of what we will do. So first I'll shortly show how you can set up a development environment so that you can hack away with Reflex. I'll give you a short bit of theory of how this FRP things work and what the two core concepts are that you will need to understand in order to write programs with it. And then the rest will be basically live coding, maybe with some extra slides at the end. So I'll show you how can you just write some hello world program, how can you make some JavaScript foreign function calls. This will be very short because we won't use it a lot, just so that you get a rough idea how this ties into the browser. Then we will look at events that happen, that typically come in from the user, some dynamic values and how you can update them, how you can combine events and dynamic values in interesting fashions, and how to deal with cyclic value dependencies when things depend on each other in turn. Then we will make some composable widgets, because one promise of Haskell-based FRP is that in the same way as Haskell composes nicely for writing all kinds of programs, Haskell-based FRP composes nicely for GUI programs. And we'll do at the end some dynamic element rendering. I'll explain in detail what that means. So we do not have in this talk these types of advanced topics that are still very interesting that you might want to research yourself, or we might talk about this another time, which is how do you make web requests. I leave this away. I only do the part now that deals with making GUI elements. How reflexes or FRP frameworks in general are implemented such that they efficiently make the state changes in your browser, also not part of this. How to reuse the code between your Haskell in the browser and Haskell on the server, for example. That works very well. I've done it for some client projects in the past. We'll not show it here though. How you can have cyclic dependency problems when you have things updating each other at the same time and turn and spinning your CPU 100%, and how to attack solving these problems, and investigating whether Reflex is fast enough in general to build Facebook, for example. We will not look at this here. Okay, so first we'll go through development environment setup. So I don't know if this works on Windows or OS X. I've only tried on Linux, but in general, the steps is the following. Like especially for this tutorial, I have cloned this Reflex platform project from the Reflex FRP main repository, with Ryan Trinkle being the main guy who develops this framework. So thanks to you, Ryan. And so in my fork, you can find this branch here, which is the Haskell's Reflex tutorial 2017. So you would clone this, you check out this branch, you would have to install the Nix package manager, and then you do the following. You do try Reflex, there we go. This puts you in an environment where GHC, JS, all kind of libraries and so on that typically take 3 hours to compile are already set up right in here. And then I have provided you with two things. First, a git log of the various steps that we'll go through now in this tutorial. So if you want to try it again at home or so, you can just do a git log on this. So you can see here the various steps we'll go through, and I also put some more comments into the code right there. So here I will write comments into the code, and I also have for you some instructions at the top. So the bit with try reflex and this loop that I will use to automatically compile my JavaScript application from Haskell every time I save it in my editor buffer. Also, the following very useful bits here to open the documentation. So we have Reflex and Reflex DOM. So if you run this GHC package field in here, it will print out the local documentation on your machine. So for example, here you would open this one with index.html, so this bit, and the corresponding part with Reflex DOM, and then you will obtain these two documentation indices for Reflex and Reflex DOM, where you can look up all the functions that are contained, and then we'll use that in a bit. Also very useful, these two cheat sheets here that the developers have kindly provided. First here for Reflex, where you can see all the functions in a very concise fashion without all the type classes attached to them, and the same thing for Reflex DOM here. Okay, so what I've done now is that from this final commit, I have removed everything except from this main function, and this is where we will start soon. So, okay, here are exactly links to those. Okay, so now comes a bit of this theory on the FRP programming with Reflex. There are only two types that you need to remember that we will use all the time. The first thing is the event type. So an event is something that happens. Typically the browser tells you about that happening, or you make up your own events. For example, if somebody clicks somewhere, that is an event. If somebody types a key, also an event. It has a type A in it. For example, if somebody types on their keyboard, this might be the character code emitted by the keyboard in this case. You can make your own events. For example, if there's a text field and you click a submit button, then this event could contain the string that you want to submit through this text field. The other type is a dynamic, and a dynamic is one of these variables that are observable. You can listen for changes, or they will tell you when they change, and they will tell other elements in your DOM when they change. So there's also a third type, which is called a behavior, which is basically like a dynamic, but you cannot listen for updates. It's just something you can query. For example, the current time. You can ask, what is the current time? You get the value back, but you won't get pinged every time it updates, because it's a floating thing. There is no concept of atomic updates to it. And then we have in here this T. And this T we will just ignore. We will not do anything with this T. This T is only relevant for the implementation of your FRP network that you're constructing there. And for us, this is always T, so we just leave it free. In the same way as you have in the ST monad, you have this S that you never touch and you can't do anything with it. Same thing here. Okay, so just a short couple of remarks that you can keep in mind as we are programming. So first, a dynamic always has a value. That typically means that when you make some dynamic at the beginning and it has to have one, that's why you have to give it a default value typically. For events, you don't have to do that, because that's just something that occurs momentarily and it might never occur. So for example, if the user taps on the screen on their phone at some coordinates over there, you might get an event with 2 ints inside. But if the user doesn't tap, then that doesn't happen. So no default values in there. And you typically create these dynamic values by listening to some events, and then you can remember when they occur, or you can make some functions that combine multiple events to create your dynamic in a way of like folding events that happen into a dynamic. That is also something that I will show in the live coding. Okay, let's get to it. Okay, right, so here's main, which is just an I/O function as usual in Haskell. And let's start my compile loop here. You call the main reflex entry point called main widgets, and then you have your widgets in here. So these widgets are a monadic function that doesn't return anything, and this is called monad widget. A monad widget is a monad in which you can construct this tree of, or this graph of GUI elements, and you can do things like render text, render like divs, spans, all of these HTML elements in there. So the simplest thing that we can do is to just like remove all of this here and just have a hello world in there. And we'll compile this, and then I always switch over to my file over here. Here comes the hello world, exactly as we expect. So now I'll start with two things. The first thing is I'll add this tutorial section combinator in here, which I've defined at the top. What does that do? It also, so it takes something that builds some widgets and returns something that takes some widgets, and it simply wraps these widgets in a div that I give a certain class. So I'll do this right now. And the main purpose of that is I just want to separate the different steps that we do here, so I need to wait until this has happened. The different steps, I just want to make like black boxes around them so that we can see on which step we're currently working, which is not occurring right here. Let's see. Oops.
You're missing the style sheet probably.
I'm missing the what?
The style sheet is still commented out. I mean, if this
sorry, you're right. Yeah, right.
Sheet, then
you're right. So here's my CSS file where I have like this border in here and a couple of things we'll do later. So let's do this here. There we go. Okay, right. So here this already shows how you can put in arbitrary HTML elements. So in this case we use an element with the attribute, we use link, and then we put in like this CSS thing into the href and say it's a style sheet and so on. And in the same fashion you can do things like, let's make some more elements in here. For example, we're going to make an L div, and inside will be an L p, and inside will be an L span, and inside will be a text I. So let's see how that goes. There we go, here's that. And of course we might want to use a indentation-based notation to do that, so most of the time I'm going to use do notation in order to create my widgets. So it's going to look roughly like this. And that will still be the same thing. Okay. Right. Okay, so standard HTML, static HTML things, we have them here. Next step. So the first thing that we want to build is a button. The user can click the button, and when this button is clicked, then an event will be triggered. So we use this function button, and I'm actually going to open it here in the docs. We have it here, button. Okay, what does that do? So it does things in some manner that can build things. Sorry, you give it a text, and this text is the label, and then it emits an event. What kind of event does it emit? Just something of unit type unit, no further information attached to it. When it happens, then this event just happened and you don't get anything extra. So this would be, click me here, this would be some event. So I'll call this button EV. I have this convention that everything that's an event, I end it with EV. Everything that's a dynamic, I just end it with dyne at the end. Okay, so what can we do with this? And now we come to this part where I'll show you shortly how to do some JavaScript FFI. And that I have over here. So what you can do in standard Haskell is that you can import foreign code, for example C code, and in GHC.js you can write foreign import JavaScript, And then you can write what the actual JavaScript function is that you want to call. In this case, alert, we want to spawn a pop-up. And the trick is now you put the arguments that you define here in the Haskell equivalent of this binding, in this case this string, you just put it right into this string that typically describes the name of this function or like the header file where you get it from. And with $1, $2 you can access these various arguments that come in here. So now I made this function here that just pops up this dialog box and that fires that fires like when an event comes in, it displays the content. So I give it an event of type A and some function with which I can render this to a string. So the ID is show, and it constructs something in this reflex moment. Now reflex offers this function perform event that allows me in this reflex mode to set up a call into native JavaScript. So in this case I have the alert function, which in this case is basically type monad.io to string to IO. And I say lift.io, okay, I have the A that is inside this event, it gets passed in over here, and I turn it into a string, then cast it to a JavaScript string because that has its own type, and then pipe it into this JavaScript native function. And we'll use that right now down here. So in this case I can say alert event, I'm going to give it the button event, and then the function that renders it to a string is like button was clicked, value is, and then I do the value here. Okay. Here's our button, and here's our alert, and we can see, okay, it's just the unit inside there. Next step. So, having events that only contain unit is kind of boring. We want to be able to attach some values to these events and replace this unit by some other things that we might have. The most simple way of doing so is by just taking a variable that we have in scope. So for example, let's say you have in some scope, x is 5 and it's an integer. And now we want to get this, we want to say if this button event triggers, we want to put this 5 into that event that it triggers. So we can do the following. After we have created our normal button event, which has type event t unit, we can say, because a event is a functor, so this thing over here, we can map a function over it to return a new event as some function computed over this thing. We can create, for example, this button event with some local value in there, and that will be of type event t. In this case, I want to put in this int. So let's put in the int. So I can simply say fmap, and I fmap my function over this button event. And in this case, I know that what is inside is that, and instead I want to put in x. Okay. So let's try that. There we go. So if I click this, oops, that's not right. Ah yeah, right, I need to not use this thing here now, so let's actually alert with this local value event. Okay, there comes our 5. So that is putting a value that is in scope into an event. We'll use that later when we build some more complicated widgets. Next step. Next step is about dynamic values. So in this case we want to make a text box, and we want to have a dynamic that tracks the contents of this text box. So let's first make a text box, and that's how you do this way. There's the function in Reflex DOM called text input, and you give it a text input config, in which case we will just use the default config, and it returns you a text input type, which contains lots of useful events and dynamic values that you can subscribe to. So let's make a text input, and we use just def, which is the default value for that, and it returns the text input t, which is also parameterized over this type, and this we call it. Okay, let's ask for the for the name of the user in this case. So this would be the name input. Okay, let's have a short look at what this is, a text input here. Text input, here you go. What does it have inside? Well, let me grab. We can get events for when the key presses happen, or a dynamic that tracks whether the thing currently has focus or not. But in this case, we're interested in the current value. So we use text input value on that thing. So we can say the name dyne, in this case, is a dynamic t text. And that is simply this value of this name input. There we go. And then we can show this like your name is, and then we use the function, let's go here, dyne text. Dyne text takes a dynamic text and displays it in the space. So dyne text, name dyne. Here we go. And I can start typing and it updates it automatically. So that's a dynamic. And you can be used for things with dynamics. We'll show a couple more a bit later. But one important thing about dynamics is that you often want to combine them. So let's say we want to build now another text box that contains not only the name, but also I put this into this class so that it gets styled nicely, or like in the right place. I want to build something that has an age inside. So I also ask for the age here, and in this case I directly use the text input and fmap over it the values so that I don't need to deal with this guy here. And then I have an age dyne. And then I want to now create a dynamic that contains some nicely formatted string, for example, hello name, your age is age. And I want this also in the dynamic, and I want that this updates when either of these two things update. So building like compound dynamic values. And for this thing, we can use the applicative instance of these dynamics. So I can say dyne text, and now I want to make this combined value. So what we'll do is we'll write some function over two things, and then we will use the applicative instance over the name dyne and the age dyne. And then inside here we will get passed the name and the age, which will be the two texts. And then we'll write some text, for example, name is age old, or it's just name is age. This is enough. Let's try it out. So now we have this, and I can change either of these, and this thing that I render here automatically updates when either of them changes. So it basically tracks this dependency of this compound value on the other two values using this applicative instance for dynamics. Okay. And yeah, this going back to this here, this concept of having the creation of some widgets return this type that contains all the things you might be interested in some pure type, such that you can just grab out the parts that you want to work with. I think this is a very nice design pattern in making these kind of, if you want to make some kind of widget libraries or GUI libraries, and I think they did a good job with that. I would follow this approach as well. Okay, so now currently we have this thing here updating whenever we type something, but in many cases you want to have some form of debouncing where you say, okay, the user can type something, but then I only want to emit an event when the user does some other action. For example, you first type down all your stuff and then you click submit. And when you click submit, only then do you want to submit and like have an event that contains the contents of these kind of text boxes. So now we are going to look at how can we combine some dynamics that are always up to date with some events that only happen at certain times. So let's do that here. In this case, I'll prepare a little bit here the following widgets. So we have we ask the user, okay, what food would you like to order? And then we have a text input, we track its value in this food input line, and then we have a button where we can order. And what we want to do now is that in the end, we want to have an event, which we call the food order event. And we want that this event contains this text that is inside the text box at the time that the user clicks the submit button, or the order button in this case. And then we want to alert this to the user and say, okay, you ordered this. So how does this work? And this is one of the times where this kind of cheat sheet really shines, because Reflex has lots of useful functions, and with the cheat sheets we can find them. So this cheat sheet is organized always in this way. It says functions producing event, functions producing behavior, and functions producing dynamic. So each of these functions produces these things at the end. So what do we want to produce? We want to produce an event, and we want to give as an input somehow, some way we want to combine this food input dyne and this button event. Okay, so let's go to functions producing event. And now we scan a bit, and then we quickly see, okay, down here we have some functions that combine a dynamic and an event. And we can just look at the types to see what it does. So you see that the type of the event is not used, this B doesn't occur anywhere, and we have this type A here. So chances are high that if we just pass in this dynamic here, it will emit an event every time this happens with the contents of this one. So let's check if this is true. Tag promptly dyne in the Reflex library. And indeed, it says here, replace the value of the event with the current value of the dynamic each time the event occurs. So that's what we want to do right here. We want to use tag promptly dyne on the dynamic and the event. And let's try this out. Here we go. I want to order some ramen. Order. Okay, ordered ramen. Here we go. So this dynamic updates behind the scenes essentially, and when I click this, then an event occurs, it grabs the value from the dynamic, puts it in, and then emits it, and I print it with my alert event function into this pop-up window.
How did you now do on the order?
On the order,
Clear the text field.
that comes in 2 steps.
Okay, I like it.
Okay. So next thing we want to do is that, so in this case we have had a dynamic and we made an event out of it, but we also want to do other things. Somehow these dynamics make up the state of our applications, right? Some variables that are there, and the events are basically the inputs and outputs that we can emit or that we can receive. So we basically have to, when things happen, we have to take these events and turn them into dynamics in order to do these state updates. So we will start the following way. So first you recall the type signature of the fold_L function, which is A to B to A. And then some default value that you start with, this is this accumulator value, so A for accumulator. And then you will receive, let's say, a list or any kind of multiple of something, these B's that come in, and then you return this final accumulator value. So for each B that comes in, you get it passed in here, and you also get passed in the current value of your accumulator, and you return the accumulator value to be passed into the next step. And we will now look at the following very useful function, which is the function fold_dyne, that takes A to B to A. So I'm just going to align this a little bit. Or sorry, in this case it's we call the accumulator B in this case. Okay, I'm just going to rename this quickly. So the things that come in are called A, and when we return the B here, that's also okay. Okay, so we give it a default value, and then we can subscribe to some event, and every time the event occurs, we get passed into our function, and our function can then combine this with the existing value. And what does this give us? It gives us, in the end, a dynamic that contains the current value of this accumulator. So we can use this now to subscribe to some stream of events, passing them in here, and then folding these events into this dynamic value. And that's what we will do now. So first, we will make this as an example based on we will render 3 buttons labeled 1, 2 and 3, and every time you click them, we will fold them into a value that will contain the sum of all the buttons that we clicked so far. So we want to have something like this, 3 buttons here, called the number button. Let's write this helper function number button, and it takes an int with that is the label and also the value that gets emitted there, and it will be its type will be event tint, and number button works in the following way. So first we want to render a button. What's the label? That's this n, which is just a number, put as a text on this label, and then it will be the button event we get out of that. Now we want that this event, we attach a constant that is in scope, this n, into this event when it occurs to replace in the unit. So we can say the number event is fmap. We get the unit in there and we'll replace it by simply n of the button event, button ev. Okay, and then what do we return? Just the number event like this. Okay, let's see if this renders our buttons. There are our buttons. If I click 3, then the event with the number 3 will be emitted. So now we want to say, okay, we want to be able to click any of these buttons and then do something. So we will collect this into one event that gets triggered when any of these buttons are clicked. So we'll make the any button ev of type event tint, and we now want to say that this event triggers when any of the following 3 guys here get emitted. So let's put those here. And now we need a function that takes multiple events and gives us multiple events of the same type, of course. So in this case, we're looking at functions producing event again, as before. And we quickly scan and we find, aha, okay, here's one leftmost. And why is this called leftmost? Because it is possible in Reflex that 2 events happen at exactly the same time. And in this case, you need to disambiguate which one you want to return, like the left one or the right one, whatever. And leftmost simply takes the leftmost one. Now, of course, I cannot actually click that fast that I can trigger both buttons at the same time. So for us, that is rather irrelevant. But still, this function is the one to use. So we use leftmost here. So now we have an event that triggers when any of these is clicked. And it will contain the corresponding number. So let's make a dynamic, we'll call it sumDyn, that contains that folds these events into an accumulator. So we will use this thing here, foldDyn. What will be the function with which we combine stuff? Plus. What will be the default value? 0. And then the any button event comes right in here. Okay, and in the end we want to show the result. So as before, we'll use dyn text, and we want to show the sumDyn, but that's an int, we can only show text, so we fmap show text over it. And here we go. Here's 0, and then I can click here, and we get these things added over here. And this is the dynamic that tracks the sum of these events. We have folded them into this dynamic. Any questions so far about this? No? Okay. Now comes your question with the clearing of this text field, basically. So let's make a new tutorial section. You may have observed that so far we always had a unidirectional data flow. we had something like a text box, and then the contents of the text box went into this dynamic, and we would render out this dynamic somewhere. So the data flows in only one direction. But let's say you have a text box which contains some string your user can type into it. Next to it is a button. That button is labeled clear, and then the string that the user has typed over there. For example, I type hello, the button shall say clear hello. Then for making this label, the data needs to flow from the text box into the button. But if I click clear, like on this button, I want that this resets the value of that thing. So the value of the contents of the text box is dependent on this value, which itself is dependent on the value, right? So there's a cycle in there, a cyclic dependency. How can we deal with that? So first we just keep trying and see what doesn't work. So first we make as before a text input like this. And we call this the text line.
So focus
okay. Then we will make a button event as before. And this button will just be labeled with clear. And then we fmap over this text line. But we just append clear in the front. And in this case, I use dyn button because the standard button function only renders a static text, and we want a dynamic text. So I have this helper function up here that makes a dynamic button, and I can quickly show it. So it uses L prime, which allows you to say what element you want to have, what shall be inside a text, and then it returns the tuple, the first of which is like a direct handle on the low-level HTML element, and then I can ask for specific events, subscribe to them, using DOM event, the element I want to have, the event I want to have, click in this case, and this returns me an event with the unit inside. So making a button just like the normal button, but being able to have a dynamic label on this button. That's dyn button. So we have this dyn button over here, and then I want to have this clear event. What is this clear event? I want to have the button event, and what do I want to do with it? Button event, and then I want to say, okay, this is something of type event unit, right? And instead I want to emit the string that shall be in the text box now, which is just the empty string in order for it to be cleared. So in this case, I fmap just const the empty string over it, like ignoring the unit that's in the event and just emitting this. So this there is of type event is t text. And now we want to say, okay, this text input here, let's go to that. The text input has text input, this one here. As we looked before, it has this text input config, and we always use default there, which contains nothing interesting, but there's also this function, or this event, essentially, set value. So we can pass in a event that which, when it's triggered, it carries a text that we want to set this text box to, and whenever that event triggers, then the text box will update its contents to that thing. So I'm gonna record update here this field, and I would send this to what event? Well, clear event, right? Because that contains the empty string in this case. It's an event t text. So that's good. So let's just close the scope here. Okay, so now we have an error because the variable is not in scope, clear event. Why not? Well, it's down here, right? So we can fix this, we just move it up there. Now it's defined on top, because in do notation you can only refer to values that are declared on top. Let's say that again. Well, that doesn't work. Button event is not in scope. Oh, that is down here. So there's no possible order in which I can order these events or these variables, because they depend on each other. It's a cycle. And this can be solved in the following way. So there's this concept already of values that can depend on each other in like some monadic notation. And you do this with a monad fixed type class. For using that, you can enable the recursive do language extension, and then you can do the following. You can say, I make a rec block for recursive, and then everything that's inside this rec block is allowed to refer to later values that are declared lexically after it. Let's try that now. And that compiles. So Reflex has a specific, is built for being able to be used with recursive do notation. Exactly for this purpose that these graphs that you can build are not only trees, but they can be trees that they can be graphs that have their arrows pointing in any possible directions, and loops are allowed. So let's try this here. So I have hello in here. I click clear, and it's cleared.
Sorry, is that monad instance of lift.io? Can you I/O?
Here, no, I don't think I can lift I/O things. Let's try. I don't think so. Ah, I can. Okay, yes. Yeah, you can do some things here. What exactly this does, I'll show this in a later slide actually. Or what would happen if you do that. Okay. Yes, actually, we'll get to this topic right now. Okay. Okay. So, how exactly does this work? So, what does this reflex monad really do? So, this reflex monad is something that allows you to define in do notation this graph of values that depend on each other. You do this setup, you do this only once. So you have this monad, it runs through it, it builds you this graph, but this happens basically at page load time by default. And this means that if you put a trace, or you put a lift.io print, for example, somewhere inside this monad, you will see that it only happens once, and not as one might expect otherwise, every time some value is updated, for example. But instead, you build the graph once, you give it to Reflex, and then Reflex will say, okay, every time something happens in this graph, I run these updates through the graphs, and the values get passed around. So in some way, this monad builds you a static network of value propagations. But of course, this is somewhat restrictive, right? Because this would mean if I have a large page with like 1,000 possible subpages, and each of them has lots of elements, then if I have everything in one static graph, the only way I can do this is hiding all the other elements by having them in the DOM, but having them being invisible. But this might not be very performant, because maybe if you have too many things in your browser, then that's not like just needs too much memory on your client side or whatever. Like you might have lots of things in there. So there is a demand that you can render some parts of this DOM dynamically. And Reflex has a nice function for this. It's called dyne. So with dyne, you are allowed to change this graph at runtime. And the way they do that is that you can, typically you just put inside dynamic values, you only put things like int, string, this kind of things, unit, right? But it has a function that you can have a dynamic that contains a rendering function in M. So you have a dynamic T and then inside some M, and that can do some things. And with dyne you can say, when this dynamic that contains a rendering function, when that changes, then run this M that is inside and change this part of the graph at runtime. And that is what we will look at now in this last step. Yep, let me quickly check what's next. Right, okay, so we'll see this in this last tutorial section. And we will also show off a little bit more here how you can combine smaller widgets into larger widgets, and we'll make a little example application essentially. Okay. So what do we want to do? Okay. Alright, so we want to build a question catalog. And in this question catalog, there will be a question, and then there will be two buttons, yes or no, and you can answer them. And our goal is that by default, like everything is just both buttons are just well, they are there, and no is default, and then you can switch yes or no. And when the no button is active, then it's red, and when the yes button is active, it's green. And the respective other button is then just gray, basically. So you can switch between the yes and no with red and green. So let's do this first, and then we'll use this later for our little application. So we want to first write the following function, color button here, that takes some given color. So that's that is, first it takes its label, what's on the button, then a color class, and I have prepared here in my CSS these color class red and green, and they are also only shown when also the class colored is set, such that we can say, okay, we want this color now to be active or not. Right, and then we want to pass in as a dynamic bool whether the color shall currently be activated or whether it shall just be gray. So that is colored like this. Okay, so what do we do here? We now want to have a button that is dynamic, not in its label this time, but instead in some of its CSS classes, basically. And for this, we'll look at the cheat sheet for Reflex DOM. We search for class, or actually, is it not here? Oh no, okay, this is not on this cheat sheet, so I'll search it in here. Okay. So with LDyn class, you can make an element as usual with some contents as usual, and now you can pass a dynamic text that builds up these classes. So in HTML, it's just a string where the classes are separated by spaces. That's why the classes is just the text in here. So we'll use that, and so we'll say LDyn class. What element do we want to build? We want to build a button. Then what class do we want to put in? We will call this class dyn, and this class dyn will be of type dynamic t text, as the API demands here. So we'll get back to that later. And then we want to put as the label, or as the contents of this button tag, we want that to be just the text with the label that we have passed in up there. Okay, so what does this return? Like the thing we built above, this returns some event, or like say all the events we can subscribe to, and then we want to get the click event such that we have here our unit we can return out here. Okay, so now we have a dynamic bool that says whether this thing should be rendered or not, and now we want to turn this into a dynamic text. So we again just fmap with the functor instance, we fmap something over it. In this case I use the flipped version of fmap that this thing provides, f4, such that I can give is colored here, and then I case on whether, I case on whether this is true. When that is true or that is false, the is colored. So when is colored is true, then I want to just use this color class, like red or green. And if it's false, I want to give the color class, but if it's false, I just want to set the color class. If it's true, I want to set this color class, and I also want to set this to colored, such that my CSS rule here with the colored triggers. So that's how you do dynamic classes on HTML elements. Okay, so we now have this color button. Let's see if this compiles. Yeah, we're good with that. We'll also need for something that we will build later, a button that can be enabled or disabled. You know, sometimes the buttons are grayed out. We want to be able to build such a button, so I'll just copy paste this over now. Which is a disableable button. It takes a label and a dynamic that says whether the button is currently enabled or not. And in this case, here we used LDyn class to have a dynamic determine the classes of our element. But in this case, we actually want to update the HTML attributes, like things like class equals or ID equals. These are attributes in HTML. So we use LDyn attr that works in just the same way. And LDyn attr takes as an argument, it takes here one second, I can maybe even show it. Yeah, here it's a bit nicer. So it takes whatever the thing is, its contents, and then a dynamic of a map from text to text where you can have the various attributes you want to set. And in this case, we want to set as the key just disabled and then equals in the the value of that thing can be, for the disabled attribute, can be anything indeed, so empty string or like disabled here as well. And so now we have this button that we can just determine that it shall be enabled or not enabled. Okay, so let us now make this kind of question widget. So one question shall contain a text and two buttons. So we have here the question text. Okay, so first we want to show, and I'll also use some CSS in here such that the answer buttons are nicely aligned. So first we'll just render the text. So in this div, we'll just put the question text as a text. And now we want to create our two color buttons. So we want to make one color button which has the label yes, and we want that it has the CSS class green. And we then also want to pass in this whether it currently shall exhibit its color or not. So this will be some dynamic to make up, but for now we just use const dyn with true such that it shows its color always, and we'll replace it in a moment. And then we'll also, so this will emit a yes event when it occurs, and then the no event from the no button, which will be enabled with no, and it will be red, and we say, okay, we also want to see the color straight away for now. And we want to see this now. We want to render here a question widget. Okay. Let's see what this complains about. Right, we need to return a dynamic at the end. I want to return whether, so let's do that right now actually. I want to return whether the last button that was clicked is the yes button or the no button, such that I can remember if this current row in our questionnaire is currently answered with yes or no. So we need a function, so we want to return this this dynamic that does that. So I'll call this answer dyn, and this will be like what we will return. You will actually return that here, answer dyn. It will be of type dynamic tbool. And now we need a function that simply remembers the last of two events, and we will override the value in here with true and the value in here with false. So for that, we first do exactly that. So as before, we want to combine two events. We'll use leftmost. We'll take the yes event and the no event, and we'll fmap const true and fmap const false over it. And I'll use the shorthand syntax here from the functor module to do that, which just looks slightly nicer. Okay, so, and then we want to say of these events that come out of this, we just want to remember the last one. And there we have the nice function hold dyn up here that takes a default value, and then every time an event occurs, it just remembers that and updates the dynamic accordingly. So let's use hold dyn false. By default, we want that no is the default selection, like that. Okay. So now we have returned the answer dyn, and of course the question widget should be like, have you something question mark, like, or maybe let's say, do you even lift, like this, and then we can also ask if they lift A2 as well. So let's try that out. Yep, here they are, and if now I set this, yeah, right, so now they're both colored, but I want that the color like switches over between gray and the color if the answer is currently yes for this row. So I need to replace my const dyn true here with whether it should be currently active or not. When shall this one be active? Well, that one shall be active if the answer is currently yes, right? So just put the answer dyn in here. When shall this one be active? That shall be when the answer is currently no, so when there is false in the answer line. So I say answer line, and then I negate that thing by f-mapping a not over it. We look at what happens. It's not correct yet because we wait. Error here. Alright, okay, so same as before. We use something up here that we declare down there. So all of this needs to go into a rec block. And we give it another try. There we go. And now I can switch between these. Okay. So now we need to build some question catalog in order to use these useful widgets that we've built so far. So what would be a good application for this? I thought it might be nice to have a question catalog for a president that can be used to determine if something can be illegalized or not. So let's start with the following questions. Let's say you're a president somewhere, you're very powerful, you want to illegalize a new thing, so you have to answer per protocol at least the following question. Have you checked with the Senate? Have you checked that that would be popular with the people? And are you really sure? So let us now build a illegalize widget that builds a question catalog for something that you want to illegalize. What do we need in this widget? So we need at least the question, what do you want to illegalize? And let's put a text box for this as well. We track the current value in the what dyne. And then we want to ask all the questions, right? We want to render these guys here for each question. So what do? We say for each of the questions, using the traversable instance of this list, we say, okay, for each of the questions, we want to render the questions widget for that text that's in each list element. So the questions widget, what do we get out of this? This will be the answer dynes, and this will be a list, because we use for here, of dynamic t bool. Okay, what do we want to do now? We now have a list of dynamics. But what we want to obtain in the end is that we want to have a dynamic that tracks all of the answers in one. So we want to have something of type dynamic t bool, and we will call this answers dyne as opposed to answer dynes, because it's only one dyne but it contains multiple answers. So we also use let here. Okay, what function do we need to use here to turn this into that? Any suggestions? What function goes from, something like this to something like this? Sequence, correct. And of course, for people who don't know this yet, there is a very useful tool. Where you can just say what you want, and then it tells you what function to use. Sequence. Okay, so we sequence the answer dynes, and then we have one dynamic with all these answers. And now we want to know, are they all answered with yes? So we make the all yes dyne, which is, we just put between all of the trues and false, we just stick an and in between, and if this evaluates to true, then they're all true. So we use the and function and fmap that over the answer dynes, over the answers dyne, and then we will obtain a dynamic t bool. Okay, so now we have something that says, okay, are they all answered with yes? And that's great. Now we want to add as a next thing, or of course just as a little aside, if you think this is way too verbose, you could also do the same thing by saying, okay, for these guys, right, this one, and then we want to just write it in a slightly shorter fashion, sequence and fmap end. But I like giving names to things, so I'll stick with the upper way of doing it. Okay, so now we want a button with which we can say, okay, sorry, that's not the right thing. A button that is just labeled legalize, and it shall be this disableable button, so it's only enabled if you have actually answered all things with yes. So we pass the all yes sign here to this disable button we've just built before up here. Okay, and as the next thing then we want to make, so every time this button is clicked, we want to update the currently illegal dyne, which is a dynamic t-text that just contains that thing that is currently illegal after you click the button. So as before, we would use hold dyne, and then we would say, okay, by default, this is the empty string, and then we use tag promptly dyne as before with the what dyne and the button, which is button event. This one here. So when that occurs, we take the value of the what dyne in here, and then you have your legalization widget. So and it contains the current thing. So let's try this quickly. So we use dyne text to show the currently illegal dyne. Okay, and let's check this out. I quit my compilation loop. Alright. Does it have anything to complain? Yes, it does. Okay. Probably.
Well, the red one doesn't
there we
have
have. Yeah, right. That's a bit better. And I also wrote a string somewhere into a type, which I want to be this. And the question is, there we go. And then of course I want to render this legalize widget. Okay, so now I can like illegalize things and click the buttons, but this text is a little bit boring, right? So, and there's also this last feature that we haven't really shown off yet, which was this concept with some things sometimes being in the DOM and sometimes being removed from the DOM. So in this case, this text there is pretty much always there, but just set to the empty string. So there are certainly some things that we still need to show off here, and that's what we will do now. So we now add this. So when you want to illegalize things, it's always good to show the people like in a big and imaginable way. So this text is a bit boring. Instead, we will use an image. So let's make a function that renders an image, but it renders this image only when there's actually something that we're currently illegalizing. So for example, if the string is the empty string, we don't want to load any image, especially because, well, what shall we put on this image, right? Just like an empty street post is not very useful for people. Instead, we better put no street post. Thus, we will now use this functionality that into a dynamic, we can stick a rendering function. That is the bit with the dynamic graph updating that I mentioned before. So let's do that. So what do we want to display? We certainly want to display the text here that's currently in the currently illegal dyne, and we want to, out of that, when we F4 over this or Fmap over that, we get what is currently illegal, and then we want to say, okay, only when that what is not the empty string, then we want to render the following widgets. Namely, the following things. I put things a bit in I made this div already here for us, and then inside I put in this little image, and then I also put some div that contains the text with the text here with blah 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 is now illegal. And now we want to say, okay, when this dynamic updates and this rendering function changes, and it does change because it depends on this what here, right? And I render this, I don't render this when this what is the empty string. For this now we use the magic function that I mentioned before, which is dying from Reflex DOM, dying which is here, which takes a dynamic MA, and in that rendering monad then, runs this function, and then also gives me back an event that tells me when it has performed that kind of rendering, if I want to do something special in this case. But in our case, I don't care to be notified when that rendering happens, I just want it to happen. So we use dying, we pass in the render image dying, which is the right type, and we ignore the return type. Okay, and then we have return unit here, and the illegalized widget, and that guy we don't need anymore. Okay, so let's see if we have everything in place. Yep, it compiles. Let's give it a try. What do we want to illegalize? Let's illegalize JavaScript, and let's answer all the questions. Have we checked with the Senate? Yes. Have we checked that it's popular? For sure. Have you checked that we are really sure? Yes. So let's illegalize it, and JavaScript is now illegal. Okay. So that's it with the demo, or the live coding. And now we are done basically, so I can just give like a little bit of my personal opinion of this kind of the state of GUI-based automatic update rendering things. So I originally started with this JavaScript library called Knockout, which was made by a guy who then later joined Microsoft, and I don't know if they still fund his working on this. And that was the first thing I used, where you could have these updatable variables, and in JavaScript they would just be functions. So you'd have normal values, and you would have these observables, and when you observe, if you want to change one of those, you would not assign them, instead you would just call this thing, like you had like X, and then you would use open bracket and put that in, because JavaScript did not have these kind of setter and getter methods that could actually do stuff. And this was relatively cool because the values inside my DOM updated automatically, but still there was this weird distinction between real values and these functions, and without type system you don't really know which one is which, and then you forget to call one with brackets, and then things don't work. And it also didn't have any kind of concept of making enclosed widgets that I could reuse somewhere else and they still would work. So no kind of composition for that. And then later, Google and Facebook made Angular and React, and those addressed or aimed to address the issue of reusable widgets. But I have the feeling that they still don't really compose like effortlessly, and I feel like even though they try, you need to set up lots of like mental and also code boilerplate. You need to keep track of which things are like props, which things are not props, and so on. And there's lots of thinking behind it. You can't just like type down the code and it does exactly what you want. And you just need lots of mechanism in order to achieve your goal, basically. So I found that this doesn't really feel like that is the ultimate solution of how we should write our GUI application. So I think that Reflex does this pretty well. So here I can really I have some very basic building block concepts, and I can understand them, and then I can build everything, and they compose nicely, and they have types which express exactly what these things are. And it's just really fun writing. It goes down in a very lightweight fashion. So I think that's really neat, and I think, yeah, I like writing things in Reflex. So what are some current problems with it? Of course, it's not all just like perfect, right? So one problem is that nobody has really built like a large page with it. So you can't really ask for advice with, oh, what kind of design patterns should I use when making something really large? Like nobody exists that can tell you that. At FPCombi we've built for one client a prototype GUI in Reflex, and it worked really well, but it was also rather like a smallish prototype, so maybe a couple thousand lines of this code, but nothing like, I don't know, Facebook's main user interface or so. Then there's also the problem that the GHC.js output is still pretty large, so this 5 megabytes blob that you obtain out of it, that isn't so great. If you compress it, it's much better. So with these 200 kilobytes that XZ compresses that to, that goes already closer to the area of what like a set of, let's say, use 20 JavaScript libraries or what. that's roughly comparable. So I guess it's not too bad. And then there is the performance question, which might be great, but nobody has measured it so far. Like, how does it really behave when you put thousands and thousands of elements somewhere and they are all observable? I found when I built something with Angular that AngularJS 1 especially doesn't deal so well because of the way that it does dirty checking with having, let's say, 100,000 elements in a table and that observe each other. So maybe this Reflex does this well, but nobody has measured. So if you do some experiment with Reflex and you want to do like an hour of benchmark or what, you can tell me about it. I'd be very interested in what the outcome of that is. Some things are known to be extremely slow. So for example, if you use ASIN to parse or construct JavaScript objects, this does not use any of the existing functionality in the browser that is native and very fast to construct JSON values. Instead, it basically runs what ASIN has, like its continuation passing based parser inside JavaScript, and that does take a long time. So for example, I learned that if I pass 200 kilobytes of JSON to my application, then I could no longer scroll when that parsing happens for, let's say, 200 milliseconds, something like this. So you can deal with that, but still, if you have, let's say, 5 megabyte JSON block or what, you have to wait, especially because this gets done on the main thread by default, so it will block your UI unless you put it into a web work or something like this. I think this is likely fixable. We have some ideas of how to do it simply by shelling out this JSON parsing stuff to the native JSON parsing function and then creating the ASIN values like this value data type directly based on what comes back from that instead of parsing character by character in the input string. And yeah, then one problem, of course, is for learnability. You need to learn Haskell before you can learn Reflex. You can deal with like basic Haskell knowledge, that's okay, like maybe some specific things like the recursive do things are useful to know, or maybe learning how to ignore all these known type class declarations in front of your functions, that is also useful to know, but you need to have some Haskell knowledge before. You cannot just take the random JavaScript developer and say, okay, now write this in Reflex, please. Okay, so now after we've seen the cons, so here are the pro points. So a great thing about it is that it's actively maintained. Like Ryan Trimble pushes out improvements to it all the time. It's easy to understand, at least in my opinion. You have these two basic concepts from which you can build everything. It has very good documentation, also including these cheat sheets. And code reuse simply works. Like inside JavaScript and between the server and so on, that really works. And it's really nice to have data types shared or validation scripts shared between the server and the graphical user interface, so you know they always agree with each other. And yeah, with the performance, at least in theory, because it knows which things depend on which, you do not need to do this dirty checking on multiple values and just see what changed. Theoretically, it can be faster in terms of performance, but it's not clear whether it is. And then there's the last very important point. Hit points. You will have so many hit points if you use this. Yeah, you will be disrupting the future with your Haskell FRP, and you will build it in Nix, this kind of stuff, while the other guys are still going through this series of JavaScript frameworks that will be invented in the future. Yeah, so that's it. Thanks. Any questions? Yeah.
How long have you been using it and how many sites have built it with?
So I have built this prototype website mainly, and we've been working on this over the course of roughly 6 months, I think, where like maybe 2 or 3 hours a day went into doing that. And yeah, in that specific case, it was something that was supposed to graph something, so we were also integrating with some external libraries, I think jQplot in our case, and it worked pretty well. That application also had some of the things I haven't shown, such as making requests and so on, and that is also, you need to like get your head a bit around it, like how these things like come back through like events and through dynamic variables, but I found it is, yeah, if you know Haskell, then this is just very enjoyable to write, and you can, like, you don't have to think about some of the big pain points that you get when writing JavaScript. And the great thing about GHCJS, as opposed to, let's say, pure script or other approaches, is that you can use basically all libraries on Hackage that are out there. Yeah. Yes?
Does it implement its own FRP engine or it uses some existing one?
No, I think it implements everything by itself.
And
Yes.
when
Reflex is the FRP engine.
Yeah, I mean, Reflex does that. I mean, in the end, the actual implementation of how it gets run in the end, I think is typically more of it is inside so the value propagation stuff is in the Reflex package, but how things end up in the browser, that is inside the Reflex DOM package. So the thing that actually signs up all of these DOM events and pushes it in, right? Those you have to grab from the browser, so they would use low-level GHCJS functions. I started, like a couple months ago, I started trying to make a console application using Reflex, where I also had to learn, okay, how can I make things like getting input from like a TTY or getting input from a terminal, how can I feed this into Reflex? And there you see where the boundaries between those two things lie.
But Reflex is in Haskell
Yeah.
fully, right?
Yes.
And probably it uses some kind of weak pointers, right, in implementation. I just heard of some problems with weak pointers in JS.
Yeah, that I'm not quite sure about. Also, I
Yes.
think, yeah.
I tried to use reactive banana, and it is affected by some bug. I don't know still if it's a problem in reactive banana or in hash maps or in something else. But sometimes it just forgets half of events, and I did some dirty workarounds, and now I wonder if like other projects like this one, for example, suffer from it too.
I haven't encountered like any problems with it so far, which is suspicious, I think. So I'm always like, oh, okay, like if you use something over the course of 6 months and you don't find a single bug with it, I think there's some bad magic going on, but so far I'm just very happy with it. So that kind of thing you described, I haven't seen that yet, but I'm also not super sure how exactly like things work internally. I think if I go on more in terms of like writing my own terminal-based implementation, I can get a better grasp of like how it really works inside.
You have an idea with respect to what kind of browsers it is compatible with?
I'm not sure. I mean, anything that GHCJS can run in will work, I think, and I guess that this works on many browsers like GHCJS emitted code.
I wouldn't expect that GCS is the problem, but the DOM APIs of the different browsers. So in fact, my reason for choosing React over another VDOM framework is because Facebook actually tested against IE8 because they have the business stake on it.
Yes, so I'm not super sure about this, but I think that probably it doesn't really have to do too much of these like shadow DOM things. Maybe it just does it like straight away, like modifying your elements in place. So I'm not super sure, but we've tested the thing that I built. I think we tested it in whatever versions we had of Firefox, Chrome, and Internet Explorer even, and I think even there it worked like as we expected. So, yeah. There was another question somewhere. Or yeah.
Did you ever need to debug the JavaScript code it generated?
Whether I do like this? Yes, there's this one. I mean, in general, you want to avoid that because, well, we can just shortly open this here. One second, I come back to your question in just a moment. I forgot to demonstrate that. So here currently there's this IMG in the tree, right? And if I do this and I legalize that, then the IMG is actually gone from the DOM. So I haven't actually said that yet. If you look in at that kind of stuff, yeah, that's roughly how what that looks like, right? So typically you don't want to go in there too deep, but I think I've had to do it only once so far, and that is when you build these cyclic dependencies between multiple components incorrectly, and you can make it such that you can accidentally trigger them in a loop that runs forever, and then basically you emit an event, it goes into the FRP evaluation and it stays there forever, and then your UI freezes basically. And for that case I have used the Chrome debugger to see roughly where it is, because the functions still have some remainders here like...
you have to look at out. The lib is the
sorry,
collection
I
of
generate the
libraries.
source network. I don't think so. I don't think you can syntactically match JavaScript, the JavaScript emitted code and the Haskell code.
There was some saying about, I seem to recall that there was some such stuff in one generation.
Maybe, but I mean, it would be very scattered around, right? So for example, like my initialized part is in this function here, and then it immediately jumps somewhere else. So it's not like you have like a one-to-one translation like you would have with something like TypeScript or PureScript or so, where you can like very easily map them together. So you would probably get some help, but yeah. So to answer your question, the debugging so far I need it only for those things. Oh yeah, and I haven't said this yet. There are some useful functions here as well in Reflex DOM, which is it's actually here. So right. So there are these guys with which you can trace dynamics in the same way as you can trace in Haskell, and compare to the like lift.io put string or like the normal trace function. These will actually trigger every time a dynamic updates, and those are also very useful if you want to do printf style debugging inside your dependent value graph. Yeah, and there was here about
Did you encounter any problems or benefits of having the state of the application distributed in this network and it being invisible, basically?
Yes, so
versus central.
In cases where I want the state explicit, I would build myself some form of like some more product type and then put that into a dynamic. And I find this especially useful if you want to build something like a website where you have different menu parts and you want to track, am I currently in this part of the page or this one? And then I use this, and then I can nicely say, okay, I have this sum type, and inside each constructor carries the state of its subpages and so on. So this works quite well. But for these GUI parts that just like depend on each other, I find it relatively convenient that you do not have to explicitly keep track of the state that you don't care about. So for example, in many cases I discard some events and so on, right, and discard some values, and yeah, I find that very positive.
Yeah. Did you try closure compiler with advanced optimization?
Yes, but I found that it does not do much. Like when I try to get the async fast, for example, or when I try to get the binary small, I never had like any real benefit of that, because if I run closure compiler and then gzip, or if I just run gzip directly, it was like 10% or something like this. And the trade-off for that would be waiting up to 10 seconds or what for the closure compiler to finish. And I did not, for our instance. I guess you could do it. I didn't find it introducing any bugs, so it still worked, which I think is positive. So if you want to get the 10%, that works. But I think that if we want to get the things smaller and faster, I think the more work has to be done on the Haskell side. And it's not so good at like magically making the things much faster.
You can just encounter many problems if you have those safe actually calls to JavaScript, then this might go.
Okay. So you found that then it just like breaks your page when you optimize?
No, sometimes. Well, especially if you partially try to use this, use strict functions in JavaScript, if you write them and then put inside this JavaScript foreign calls to JavaScript. If you put it safe, then it wraps it around like try catch, and then if you have inside some functions, some browsers will say that it's like illegal in strict mode to have defining functions inside try catch blocks.
Okay.
So
okay.
It's a problem.
Yeah, so the consensus then seems to be to like, not try to optimize that with this compiler.
Well, I decided to always try to keep it compatible, and I just try all the time on different browsers if it works after advanced optimizations.
Okay.
But it's just a matter of, I think, especially if at some point we decide to update this JSON library, for example, and containers library to have some low-level JavaScript implementation, it will be probably hard to maintain this compatibility with advanced optimizations.
Yeah.
Cool. Thank you very much, Niklas. And as usual, there's space reserved for pizza and beer in Jimmy's Pizzeria for the ones that still have some time left and want to join.